25. This is given. AD is parallel to CE. BD is congruent to BC. And you are supposed to prove triangle ABD is congruent to triangle EBC. And they have a picture that looks like this. So, we're going to have our statements and our reasons. So, what are the first statements we always put? Yes.
AD is parallel to CE.
Good.
And then given.
And what else?
Oh, should we put BD and BC too?
Yeah, you might as well put everything at the top.
It's like when the ones you make on your own, what if you can use it later? Do you erase it?
No, you can leave it right there.
And then use it twice?
Oh, you don't even have to write. If it's already up there, you don't have to write it again. That is given.
So just write given.
That's why I always take my first ones and I write my givens at the top, and then I think, all right, they're done. I can use them later on, but I don't have to ever write them again.
Oh.
Okay, so the second step. So when you have parallel lines, what can you prove are congruent using parallel lines? Just in general. When you have parallel lines, we looked at parallel lines. What did we prove were congruent using parallel lines?
Their slope.
Not their slope. Their slopes are the same. But what are congruent? Did we prove that the lines were congruent?
Yes.
No.
No.
What did we prove? What kinds of things? Angles. We proved that angles were congruent. Specific angles. So, if these two lines are congruent, let's say they're cut by this transversal, so we're not looking at this one now, we're looking at this one. Which angles are congruent and why? So this line we're looking at. So if it helps, I'll erase this. So we're just looking, I'll put it back in a minute. So we're just looking at these two lines and this. So what can we say? Yes.
Angle A is congruent to angle E.
Good. Angle A is congruent to angle E.
Right?
And why is that? Can you tell me?
Oh, is it because like they're the ones with the angles and they're connected?
What kind of angles are they?
Vertical.
No.
Oh no, sorry. I don't know what angle they are.
Okay, so if we were to extend these lines, alternate interior, good.
Oh.
So they're alternate interior. Good. Now I'm going to draw the triangle back together.
Okay. I think I can connect them two.
And so we have angle A is congruent to angle E. So I marked it up on my thing. Okay. And now we use this line. What's another thing we can say is congruent? Go ahead.
Which one? Yeah.
Wait. I can't tell what's E and it looks like
E. This is an E.
Yeah, E and.
You already said E and A, so E and A are taken care of.
D and C.
Oh my God.
D and C, good. I'm just say D and
Yeah, Tommy, just chill.
C. Shh. Why? What's the reasoning?
Because they are alternate interior. No.
Yes, that's correct.
Interior angles.
They are also alternate interior angles. I'm writing alternate interior angle theorem. And I'm going to mark them. So, now that we have a side and two angles, can we say that the triangles are congruent?
Yes.
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 However, we have two theorems that within two angles and a side that say that two triangles are congruent. They are angle side angle and angle angle side. Which one are we going to use to say that these two are congruent? Are we going to say angle side angle or angle angle side? So ASA or AAS?
AAS.
Good. Who said that? AAS?
James.
Whoever said AAS was correct. Can you explain why?
Because there's two angles and a side.
Because there's two angles and a side that's not included, that's not between the two. These two marks are parallel. That doesn't mean they're congruent. So the sides that are congruent are outside the two angles. So we say angle, angle, side. And just to be clear, this is a B.